We're going to go through the answers here. Make sure you guys have them correct. If you made a mistake, fix it, because I want you to have accurate answers for this for you to prepare for tomorrow. Okay, so for these, we are converting between standard to scientific. So I'm going to put my decimal after the first non-zero digit, and then I would have to move it to the left 2 places to get it back where it started. So right away that tells me I'm going to have a negative exponent. So I have 4.056 times 10 to the negative 2 as my answer. Okay? If you made a mistake, remember, fix it. All right, number 2. I'm going to put my decimal after my first digit. It would take 4 loops to the right to get back to the end, or at the end of the number like it should be. 1.35 times 10 to the 4th.
Oh, so that's what you meant last time, right?
Yep.
I got it right.
Good boy.
Okay, number 3, we're taking the scientific notation and we're putting it into standard form. So because this is positive 4, I'm going to take 1.12. I'm going to move my decimal 4 places. Fill in the 0, missing placeholders. And my answer is 11,200.
I made a whoopsie. Yeah, I went the wrong way.
And then for number 4, I have a negative exponent.
Oh my gosh.
Move it to the left 1 place, so my answer is going to be 0.723. If you don't have the 0, it's fine. Just make sure your decimal point is like super obnoxious. So I know that you put 1 there. Roman, did you have a question? I'm sorry? Okay.
Chechen's big muscles.
All right. Number 5 and 6. Remember when we multiply, we just take these first 2 digits, 2.7 times 6. So I get 16.2. And then when I multiply 10 to the 4th times 10 to the negative 2, when I combine those, I get a positive 2.
Yes, I got it right.
However, we're not done yet, because that's not in proper scientific notation. Xander?
Decimal 1 over.
So I get 1.62 times 10 to the, what's my exponent?
Oh, 3.
3.
Yes, actually I did.
Okay.
Add 1 to the 2 because
You don't know my worth.
Okay, so the difference here, take a look up here, please, is I was going to move, everybody look up at the screen. I was going to move 2 places, right? Well, because I had to shift the decimal here, now I have to move 3 places to get where it was supposed to go. So that's why my exponent changed, right? Because 16.2 times 10 to the second equals this, but this is just the proper way to write it in scientific notation. So I'm not changing the value, I'm just changing what it looks like. Okay, so then for these, when you guys had Mrs. Reynolds, hopefully you worked on putting them into standard form. So I would move this 2 places,
Yeah.
and then I would move this 3 places.
Yeah, I didn't see that either.
So then I would have 525. Please stop with the noises. I made sure that I lined up my place values, right? I talked about that a lot in the video. So then I add them. But then the last step is I have to turn it back into scientific notation, right? So I'm going to put my decimal here. It would take me 3 loops to the right. So it's going to be 9.625 times 10 to the 3rd.
3 loops. I didn't know.
You forgot to put it in standard first? Yeah, because you will not get the same answer if you just try to add the numbers. Because these different exponents tell you they're going to have a different number of digits. But that's why we're going over it.
Same.
Okay. Yeah. Give you guys a second to copy that down if you didn't have it correct. Then we'll go on to page 2 and talk about the different basketball arenas. Right?
I saw it on the last second one for like a good 5 minutes on the basketball one.
Okay, we're going to go over it. All right. All right. Turn the page. What we have here are basketball teams and where they play, right? So really, the main point of this problem is to see we have the distance from New York to LA, and then we also have the distance from Miami to New York. That's where those different arenas are, okay? So we're going to use this information to figure out how many times further New York is from LA, from New York to Miami, okay? So by how many times further, we have to divide. So 2.8 times 10 to the third divided by 1.4 times 10 to the third.
We use calculators for this.
You may not. Nice try, though. You shouldn't need a calculator. Come on now. They're not terrible. So I'm going to divide these. 2.8 divided by 1.4. I shift the decimals. How many times does 14 go into 28, Dimitri? 2. So now I have 2 times 10 to the, what's 3 minus 3? 0. Anything to the 0 power is? 1. So what's 2 times 1?
2.
So my answer is 2 times further.
You have to write times further.
Yeah, because that's what it asked. How many times further? Farther, further. I think it should be you. Yes, Chris.
I put them into like
Standard form?
yes, standard form and then divided. Is that alright?
Yes, if you can do that without a calculator, that's fine.
Oh,
Yeah, I did
Yep.
the same thing.
I'll take it.
I did.
Yep. Did you get the right answer?
Mhm.
Great.
Good job, Chris.
Oh yeah.
Go Chris.
Okay, now we want to know the actual distance. How much further is one to the other? So we have the 2.8 times 10 to the third minus 1.4 times 10 to the third. So we get 2,800 minus 1,400. Once I move all those decimals and change them. Yep. So we don't even have to put that back into scientific notation. Our answer is just 1,400 miles.
Mill.
Probably. If I don't do it, I get the whole thing
No,
wrong. We'll get it wrong.
you might get like
Put it into
a little bit off.
scientific notation.
That's fine. I would count it. So you had 1.4 times 10 to the third.
Oh, yeah.
Take it. I'll take it.
Okay.
Same value. Okay, last page. Fair game review.
Uh-oh.
Everybody's favorite.
Nope.
Oh, I thought it was 15. I guess not every single one.
Okay, here we go. Remember, rational numbers are numbers that can be written as fractions, and irrational numbers are crazy, right? So based on the fraction thing, how about number 1? Is that rational or irrational?
Rational.
Of course it is. It's a fraction. It can also be terminating decimals. So this one will also be rational. Terminating decimals. How about number 3?
Irrational.
Irrational.
Why, Xander?
Because it's a repeating decimal.
Well, it's not repeating. It's a non-terminating. This dot, dot, dot tells me there's nothing happening here, right? So that's our signal. If it was a repeating decimal, that would be rational, right? Because those can be written as fractions. And then this last one is a non-perfect square. It's also
How was your guessing abilities?
okay. And then down here where we're estimating, right? This is going to be between 4 and 5. It's closer to 5 because 21 is closer to 25 than 16. So I estimated this like 4.6. Or if you put it at 4.5, I would take that.
Is it just like the range? Does it have to be exactly right?
Just put it like it should be,
4.4.
I mean, well, anything over 4.5 and about, like in between here I would take. Square root of 24 is about 4.9, right? That's almost 25. Plus 0.5 gives me about 5.4. So this is where I would put B. So this would almost be the square root of 25, right? So I know it's going to be really close to the number 5, but not quite 5. And then I add the 0.05 to that, 0.5 to that, and I get 5.4. This we all know is about 3.14. So this is where I would put C. And then there's a typo here for D. I'm sorry I didn't see it before I passed these out and made the copies. This would equal square root of 4, which then equals the whole number 2. So really that would go down here somewhere. Right, because 36 divided by 9 is 4. Square root of 4 is 2. Yep. There will not be a mistake like that on the quiz, I promise.
Phew.
Phew!
You should do it like that, where it's even numbers. So we
Questions? We can go to the group.